Hello, hello. This is Exam Slam. There was one and only Exam Slam on Thursday. So to get points, you'll need to submit this piece of paper and you have to take notes. So it's more about the notes, not about circling answers. So let's do it. I'm actually not going to do this one first because I think this one will make more sense when we do some of the other ones. But let's start on this one. It says match the cross section of each solid with the one on the left. So they're demonstrating here, it kind of looks like a hula hoop, and if we chopped a hula hoop and we opened it up and we looked at it, it looks like this would be the cross section. Here, it's a vertical cross section of a cylinder, which, if you have trouble seeing this, you could also think of it as the shadow puppet. Okay. I think it's wobbling a little bit. Sorry about that. Okay. So, now they did get a little tricky here. They flipped this thing on its side. But other than that, it's definitely this one. Here they're chopping a triangular prism. A lot of people think that's a pyramid. That is a prism because see how it has these rectangular or parallelogram faces? It has a triangle base on the top and the bottom, but rectangular faces. So that would make this cross section. And last but not least, very hard to see, but it is in fact, they have tried to slice what looks like a tennis ball. And that would be this one. So, in fact, all cross sections of spheres are circles. Interesting, because it's just no matter how I cut it, vertically, horizontally, at an angle, I'm still going to get circles. All right, next problem. It says here that Jennifer loves snow cones and she wants to get the most for her money. So the same shop has these two options, cone or cup, and they're the same price. So we basically want to know which one's greater. So let's do that. We first have to know the formula for a cone, and this is a cylinder. Okay, so the volume of a cylinder is the area of the base, which is a circle, times however high I stacked those circles. So we have the height, but we don't have the radius. So that's the little trick here. From the center to the edge is the radius, and so the radius would be 4. Now, we've got everything we need. Let's plug it in. So the volume would be pi times 4 times 4 times 5. So that would be, let's see, 4 times 5 is 20. 20 times 4 would be 80 pi. Okay. Now, what's next? We have to compare this one. So let's do the volume of a cone also has a circular base, and also the circles were stacked a certain height, but the circles got smaller, so we have to remember to divide by 3. Now, this time we have our radius and our height, so we are good to go. So the volume would be 4 times 13, divide by 3, and then that pi right there. So if we take a look, this one might turn out to a decimal, but 4 times 13, divide by 3, I get 69.3 repeating pi. So I don't really need to find the volume because I can kind of compare at this point. It looks like the cup, not the cone, is bigger. So this would be the better value. Now, if you want to keep going, what would be the total volume? So we could multiply by pi. 217.8. So this is 217.8. And this one, we're multiplying 80 by pi. 251.3. 2, 5, 1.3. Notice again, the cup is bigger. So you can compare in terms of pi, or you can just find the whole volume and then compare. All right, so let's build on that. We have a composite, and that means a combination or in addition, the two together. So I want to know the total volume of this object. Well, you should notice that this piece of it is a cylinder, and this part of it is a cone. So it's similar to the last problem, but I want to find both of them, and instead of compare, I'm going to add. So the volume of a cylinder is the area of the base, and the base is a circle times the height. And they've given us the radius is 3. So 3 squared times 7. So that's kind of interesting. They laid it on its side, but the height, they're stacking circles a total of 7 inches high. So the volume of our cylinder is 3 times 3 times 7. That would also be 9 times 7, or 63 pi. Fabulous. Now, let's look at our cone. Once again, this same formula. Do write it out because, again, these you'll have to memorize, not provided on the test. So pi is 3 times, and the cone is 4 inches high. But again, we have to remember to divide by 3. So we get 3 times 3 is 9. So that would be 9 times 4 divided by 3. So 9 times 4 is 36. And when we divide 36 by 3, we get 12 pi. So it's pretty easy to add these together. I have 63 pi for my cylinder and 12 pi for my cone. That gives me a total of 75 pi. And interestingly enough, I can stop there because it says, please answer in terms of pi. Now we're ready to do this question. Cool. Now that we've gotten our brain thinking about how things compare, we have 2 cones they'd like us to compare. So I'd like you to draw these cones here. And they'd ask us to compare them with each other. It says they have the same base radius, okay? Radius is the same, whatever number it is. So maybe if the radius was 5, that means this radius is 5. That's what they mean. It's the same. The same height. Boo! It's the same height. Wow. Okay, so it pretty much sounds like, let's say the height was 10. It doesn't matter what it is. If it was 10, then this one also has to be 10. So right off the bat, it sounds like these are equal. So are they going to change some of the facts so they're not? Well, now it says, what if one was right and the other oblique? So we know the word oblique means slanted or sideways. So I believe what they mean here is, what if we can also think of a cone as stacking circles. So one great analogy is if that would be a $1 piece and then a 50-cent piece, maybe that's a quarter, a nickel, a penny, a dime, it would start to look like a cone because I'm stacking circles that are getting smaller. Now that's a good way to explain what an oblique cone would look like. That's like, imagine these coins and I push them against the wall. So I have the $1 piece, the 50-cent piece, the quarter, the nickel, the penny, the dime. It's still the same object, still exactly the same height, same radius. However, now it's at a right angle from the wall, and this is sideways. It should make sense here that the coins are still the same. The coins take up the same volume in the universe, so just because it's squished against a wall doesn't mean the volume should be different, and that's our selection. All right, now let's try to do one here on the back. So let's see. It says when the plane crosses parallel to the base, these are parallel to the base, we should get a circle, okay? Because it was made from stacking circles. When a plane is perpendicular to the base. So here's the base, and they're trying to kind of draw a shape perpendicular. Well, if it's hard to see or imagine this, think of our shadow puppet. Our shadow puppet is the vertical cross section, and that makes us think, oh yeah, that would make a triangle for a shadow puppet. And last, what if you did one sideways or oblique? That would give us an oval because it's smaller up here at the top. That's where the circles are smaller, and they're bigger down below. So that would give us kind of a shape not quite a circle, a little bit modified. Awesome. Now let's keep going. I'm looking at question 26, and I see it says they threw us a curveball. List the sides greatest to least. So I gotta be very careful. We're used to listing stuff least to greatest. So I gotta be careful with that. Also, we're used to just listing one triangle, but they gave us two. So if I have to list something greatest to least, then I'm willing to bet that the bigger triangle, all of the sides of the bigger triangle are going to be greater than the smaller one. So let's start here at the bigger one. So if I compare the three angles, first off, I have a problem. I don't know all three angles. So using the triangle sum, 25 and 27 is 52. So 25 and 27 is 52. Now we know that the third angle has to help add up to 150. So 180. 180 minus 52 is 128. So that tells me, and we can double check our answer, that angle would have to be 128 in this triangle. Now, we normally order them least